Hi, this week we're going to talk about guidelines, principles, and theories. And as we go through this particular content, I'm going to break the content up into several videos. So this is the first of them, and we're going to talk about guidelines and principles. And they're guidelines and principles for effective computer-human interaction. So it's really talking about the interfaces that you would use as you're designing your systems, whether they be a website, whether they be a mobile app, whether they be a computer program. Okay. So some of the guidelines include best practices, a shared language that everybody who goes to do whatever you want them to do, they understand. It's a common language. Critics say it's hard to do because getting that commonality is very difficult. But proponents say that by doing that, you are able to enhance the experience for more people. So let's talk about what that means. So when you look at the user interface design, is you're going to see here in this particular model, it starts with the requirements definition, and that's where you talk to your users and find out what it is that they're looking for. And that will depend upon the demographics of the users, and we'll get into that in more detail. Then we create a concept, and it's a detailed design, and the design then becomes even more specific as we then really narrow it down so that we can go to the validation stage, which would be actually testing. And that's testing of two types, testing of the functionality and testing of the user interface. Something can be very functional, but it could be difficult to use, and that's what we have to check here. And then we research, we check to see, what do our users say? Did the functionality do what it was supposed to do? And this is what we call a life cycle, because we continually then refine our requirements, we do modifications, enhance our design, test it, and then we check it. It's a continuing cycle. So in navigating the interface, there's a couple of things that we want to do. One of the things is called standardizing the task sequences. And what that means is that if you have people enter information, for example, this is just an example, you have them perform a task, and maybe what the task is you have them enter information about maybe their demographics. Every time you do that, you use a very common type of form to be able to do that. You always have them, when they're shopping, for example, you have them always click on the item, validate that the item that they clicked on is what they wanted to do before you have them check out. It's a common, similar experience. The task sequences are the same. You ensure that all the embedded links are descriptive. So for example, you wouldn't just have go to a website, but you would explain what is that website. You would use unique and descriptive headings, and that's very important, especially for websites, because if you are looking at universal design and you want to be able to capture people who are hearing impaired, they utilize a software called JAWS, and JAWS actually will read the headings, and it will say, heading 1, man goes to jail. Heading 2, dog wins race. Heading 3. And each heading is indicative of the significance of that article. Okay, check boxes for binary. We all know it's much easier to check a box and have to fill information in. Develop pages that print properly. How many of you have tried to print airline reservations? It's a big pain. They sometimes print on 3 pages. There's stuff you don't want. But formatting your whatever you have, whether it's your invoice, airline reservations, whatever you might want your customer to print, formatting it so that it can be a PDF that either can be printed or saved on one page is very important. And then providing thumbnail images so that the user can then select which ones to look at. Amazon does a perfect example of that. They get a lot of thumbnail images on a page, and then you pick the ones you click to pick the ones you want to see in more detail. So sample task sequencing, this looks fairly complicated, but this is I would call it a process design model, of which this is showing how somebody goes from making an appointment to having a consult for a head and neck radiation oncology. It doesn't sound like very much fun at all. One thing I do want to point out is the colors. The colors generally all are the same for a specific group of items that are related. So in this particular example, you see the the different symbols, the diamond always mean there's some decision that's being made. You know, you either do something else or you there's a choice always with the diamond. Go here or you go down. And there are different choices. But you also see that there are processes. Usually these squares are processes. And you also see that there are operations. So, okay. So accessibility guides is something that is important because we want to look at how are we addressing people of all different types, whether it's audio impaired, visually impaired, or kinesthetically impaired, or just physically we have some kind of impairment. You know, we want to be able to provide equivalent methods for all different people on a real-time basis, and you know, make these alternatives available to everybody very easily. So, for example, when you're designing whether an app, an application, and you're making it visually, you're visualizing, making it something visually that the customer will select from, you have to be concerned with color. So in looking at this, can you identify the deer here in the different colors? There's a blue tail, pink, orange antlers. So not everybody can see that, and maybe you can't. That would imply that you have some level of color blindness. Here's a bear up here. Here's a, looks like, I don't know, a snake, I'm not sure. Anyhow, looking at understanding that other people cannot always see the same things you do is very important. You know, and then optimizing the display. We want to make sure that we don't put too much stimulants on a page because it's too much for A, the user to memorize, and B, there's only so much that the user can assimilate. We like consistency of data. So how do we get the user's attention? These are the factors that we look at. Intensity, marking size, inverse video. So for example, if you have a white page, your video is got a black background. Blinking, some people like that blinking. I think flash is not as in vogue as it used to be. Instead, you see more of a gentle movement on screens. Color, we just talked about. Audio. Audio needs to have something that is controlled. There's nothing worse than clicking on a screen and having it start yelling at you when you don't choose it. Size, choice of the fonts. You know, there are rules for all of these things. So I want to go to this website. This is the New York Times. So when we look at the New York Times website, one of the things that we really like about the New York Times website is that it's very clean, it's got columns, but if you look at the colors, it really has only a few different colors. It's got the black, it's got the green on white on green, it's got dark black, it's got some gray, it's got some bold, but it's very careful as to how much color it uses. You look at the pictures, for example, each of the pictures are actually hyperlinks to something important that you can go and look at. This is apps to make you recipe for home bartender, scroll, tap, and pour. So this particular website, as you can see, has taken a lot of care to follow the design rules. A lot of information, but it's very clean. So what are some of the principles? One of the things that we have to consider when we're looking at principles is user skills. What are the age, the gender, cognitive abilities, training? So for example, if you're designing an app for people between the ages of 10 and 14, these people are digital natives. They're able to use their phone to the maximum ability. They're able to navigate very quickly, as opposed to people who are in their late 70s and 80s. These people are not able to figure out the actual nuances of technology as quickly because they didn't grow up with it. So simpler design depending upon the user. Also, we want to know about, whether this is a novice user or whether this is a person who's been doing something for a long time. And when you're looking at the skill level and doing design, you want to look at, will this be something that somebody, once they learn it, they'll be doing it all the time, so they become frequent users, or are they going to be intermittent users. For example, when I worked for Siemens and we had to develop systems of healthcare information systems, and we had different populations of people. We had the business office people who day in and day out, all they did was work with the computer. Those people, they learned it. It could be very sophisticated, but they knew that workflow. They knew how that system worked. On the other hand, I would have a cardiologist specialist who would come into the hospital, maybe that hospital, maybe once or twice a week. They were in what we would call intermittent users. It would take them a while just to remember the basic things that they did the time before. For those types of users, you want to have a different type of presentation, something much simpler. For nurses, for example, they had to know the system very well. They had to be able to learn all of the nuances for their skill level, plus be able to assist doctors or phlebotomists that might need addition. So understanding your user, understanding the frequency, it requires you to create these multi-layer designs. So one of the things in the task analysis piece, when you're doing any kind of user design, is you're looking at who are your users. So table is a perfect example. In this particular table, we have our users being nurse, physician, supervisor, appointment personnel, the medical record person, the researcher, and the database people. Then we have these different tasks. So one is you query by patient. So that would be like doing medical procedures on patients. One of them is like update data. So for example, maybe taking heart rate, on a regular basis. One would be looking at all patients across a continuum. One might be just adding some relations like, family members, or another one would be evaluate the system. So actually, the evaluate the system, the database programmer should have had a greater role. But as you look at this, so just for the very first one, the number one query by patient, it's the appointment personnel. That person who is scheduling the appointment. The next person who queries by patient most often is going to be the nurse. Updating data, well, it's not the appointment person, take note, but it's the nurse who's doing the procedures. The physician who's putting in his notes. The supervisor who might be looking across multiple patients. Okay, the medical record maintainer who's looking at, different, making sure that the hospital personnel did what they were supposed to do. Query across patients, well, that's going to be the supervisor, medical record examiner, the researcher, and the database programmer. So you can see by task how different positions have different frequencies. Okay. Now, when we're choosing an interaction style, which is how are you going to interact with the computer, there's several different methods. One method is the direct manipulation. Direct manipulation, Apple is, I think, genius at direct manipulation. And it's when you take a document, for example, and you move it into the trash can. It's like utilizing icons, picture to picture, to be able to do what you want to do. The user controls that process. Menu selection. Canvas is a perfect example of menu selection. We select what class we're going to go to. We select whether we're going to look at the syllabus, whether we're going to look at the module, whether we're going to go to the discussion board through a menu. Form fill-in. That's one in situations where you're going to be filling in a form. We have situations if you're doing any kind of purchasing or you're signing up for a newsletter, you have to fill in your name, you have to fill in your address, you might have to fill in a phone number, you might have to fill in a date. So creating forms so that they're simple to fill in, but also so that the data that goes in there is of a high quality data, that it is valid. Command language. Now, command language is for more of a sophisticated user, where you would say start program, where natural language would be something where you might just, when I do a Google search, how do I add a table to my APA document? So looking at the spectrum of directness, an example here is just being able to, for example, this one is the command line where you would actually type something in, like as if it was just an IT command. DOS used to be command line driven, for example. Form fill-in, here's the perfect example where you give exactly how you want that date to be filled in, MMDD. It always drives me crazy when they don't tell you, and then I'm like fooling around, and then it keeps telling me it's invalid, but they never tell me what it's supposed to look like. And here, if you look here, it says improve form fill-in to clarify and reduce errors. You know, they're very clear. Put that there, DD. Okay, pull down menus, we know about that. 2D menus, Google, that's what we do. So what are the 8 golden rules of interface design? This is important no matter what type of design you're doing. Programming, system, website, apps. We want consistency. You don't want on one page to say, if you're presenting numbers, to have it sometimes be a whole number and 1 decimal, and then another one, a whole number and 2 decimals. If you have percent, have the percent always look the same. You want to cater for universal usability, universal design. We talked about that, being able to, for headings, identify the type of heading, put descriptions under any kind of website name, under any kind of picture. Offer informative feedback would be examples of providing feedback when people enter information in properly, and also when they enter information in and it needs to be fixed. Let people know when they're finished. Design dialogues to yield closure. So when you've completed something, if you haven't, you've gotten feedback saying you need to fix it. But when you have, you say, good job, or you put a check mark every time they've finished whatever they need to do. Design so that when they enter data, that it's error-proof. You've given them the prompts to be able to take the data and enter it in properly. And if it's not, allow them to just do the backs, reverse the actions without having to do the whole screen. There's nothing worse than having to redo the entire screen if you had an error. And people want to feel like they're in control. So giving them feedback along the way, allowing them to pick and choose what they're going to do. And reduce short-term memory. Just think how awful it would be if you were on Amazon and you were identified things that you wanted to purchase, but you had to remember that ISBN number or whatever the product number was, and you had to put that into the shopping cart. That would be very difficult. So creating your system such that data from each screen is able to carry over to the next function. Okay, so we talked a bit about preventing errors. This is one of my favorite things, automation versus human control. Humans generally are better. They detect stimuli in a noisy background. We have senses. We're able to utilize greater ability, not just eyes, but we can feel things, we can smell things, we can hear things. Whereas machines, they can't do it. They are programmed to do a particular function, and the house could be burning down, but they won't know. But computers can store lots of information, and they can also do decisions. There is, as artificial intelligence becomes more pronounced and refined, you're going to see computers being able to store far more information than the human mind can store, and to be able to make decisions based upon that. Computers are able to do several tasks simultaneously. People sort of can do several tasks simultaneously. We multitask, but our multitasking means that something else is being put by the side. We concentrate on important tasks when overload occurs. The computer doesn't know what is more important than something else. The one thing to remember about the computer is the computer has to be programmed by a human to do everything it has to do. Even when computers learn, it's only based upon information that humans have given it. So users can avoid certain things. So there's certain tasks that we give computers. Mathematics, adding, subtracting, dividing, percentages, routine error-prone tasks. Computers are perfect for. And this allows us humans to concentrate on critical decisions, coping with unexpected situations, and planning future actions. Thank you for participating in this presentation, and I look forward to getting your feedback. Bye-bye.